Good morning, everybody. Today we are going to start out our final lesson on scientific notation with a warm-up. I'm listing 4 problems right here that I'd like you to try. Go ahead and pause this video and give them a shot at this point. When you're done, resume, and you will be able to see the solutions. All right, here are the answers to the 4 warm-up questions. To explain, let me zoom in here. The first one was 4.8 times 10 to the 10th. The decimal point is currently right here. You have to get the decimal point between the 4 and the 8 because that makes the number between 1 and 10. So you count 2, 3, 4, 5, 6, 7, 8, 9, 10 spots you have to move. Therefore, it's 10 to the 10th power. Here, you start the decimal point here. It needs to end up between the 4 and the 8 again. 1, 2, 3, 4, 5, 6 spots you have to move it to make the decimal 4.8, which is between 1 and 10. So -6 goes here because you moved to the right in that case. Generally speaking, again, if your power is positive, you have a very big number like this. If your power is negative, you'll always have a very small number like this. Both are greater than 0, right? But one is very small and one is very large. All right, here's number 3 and number 4. 4.6 times 10 to the 3rd. So the decimal point started right here, and you had to move it 3 spots. 1, 2, 3. So 4,600. Number 4 is 3.9 times 10 to the -4th. So your decimal point started right here, and it moved 4 spots to the left to make the number smaller by a power of 10 4 times. 1, 2, 3, 4. So there's your decimal point right there. Let's take a look at a couple word problem examples involving scientific notation. I really like example 1 because it involves a couple different operations. We are told here that this deuterium and tritium are hydrogen atoms. Deuterium contains 1 proton and 1 neutron. There's a proton, there's a neutron. So both of those together will create deuterium. And tritium has a mass of 5.0224 times 10 to the -24th grams. So we're given that. What is the difference? What's difference mean? Difference means subtraction. So we want to find the difference of the mass of tritium and the mass of deuterium. Well, first we got to figure out how to define deuterium. Deuterium is going to be these the proton and the neutron added together. We have to add these together to define deuterium. We can do that if you recall from the previous lesson. If the exponents are the same, in this case they are both 10 to the -24th, we can just combine the coefficients. So if we combine 1.6726 and we add 2.6749 together, these stay the same. This does not change. When we add and subtract, the exponents do not change, but we can add the coefficients together since they are common exponent bases and powers. And so when we combine those together through addition, what we get is 4.3475 times 10 to the -24th. And I want to find the difference between tritium, which is right here, and the deuterium, which I just wrote. The difference is subtraction. So I actually want to do tritium, which is this, minus this. So I'm going to write my new problem, which is 5.0224 times 10 to the -24th minus what I just found for deuterium. Now notice that again, these are the same. So I can combine these coefficients through subtraction. When I do that, I will get 0.6749 times 10 to the -24th power. And that is not in scientific notation, folks, because this number is not between 1 and 10. 0.6749 is too small. So I have to convert it to scientific notation by moving the decimal point 1 place to the right. So that would create 6.749 times 10 to the what? Well, I made this number 10 times bigger from here. So to compensate for that, I need to make this one smaller. What's one smaller than -24? One smaller is -25. So that would be my solution for this question right there. Okay, let's look at the next example. It says a carpet can contain millions of dust mites, and then you're given the length of those dust mites right here. If a carpet has 1 million dust mites and they all crawled away single file, how long would the line be? So the challenge of these types of problems, boys and girls, is deciding what operation do you need to do. In the previous problem, we realized that we had to add together those two protons and then do a subtraction problem after that. Now here it's a little different. Each individual dust mite is this long, and there's 1 million of them. So how long would that be? Well, we're going to have to, in this case, figure out the total length. Each one is this long, and there's this many of them, right? So if I asked you what's the total height of, 3 people that are each 6 feet tall, well, you would do 6 feet times 3, right? Because there's 3 people. Now, this is the same concept, just more complicated numbers here. So we got this very small dust mite, and there's 1 million of them. We're going to have to multiply these two together. So we're going to do 2.5 times 10 to the negative 4th times 1 million. I'm going to write 1 million over here for a second. 1 million, how could I rewrite that in scientific notation? Currently, the decimal point is right here, and I need to get it over here to make it between 1 and 10. So that's 1, 2, 3, 4, 5, 6 spots I'd have to move it. So I can rewrite a million as 1 times 10 to the 6th power. All right, so this is the problem I have here. So I multiply these together, and I get, when I multiply, remember you keep the base and you add the power. So negative 4 plus 6 is 2. And then with the coefficients, I can just multiply these together. Coefficients, you just do whatever the problem tells you to do. So 2.5 times 1 is 2.5. So we have 2.5 times 10 squared. So that would be the total length of that line of dust mites. Makes you want to vacuum, doesn't it? Sticking with the bug theme, let's continue this next problem that has to do with beetles. Here we are told a line of beetles is this long. How many beetles would there be? Okay, well, this is a different type of thinking. Here's the length of each beetle right there. So if we know the total length of the line, and we're given the length of each individual beetle, and we have to figure out how many beetles will fit inside of that line, now we're talking division here. So here we need to take the length of the line, which is 1.25 times 10 squared, and we need to divide it by the length of each beetle, 3.1 times 10 to the negative 3rd power. And that is going to tell us how many beetles would fit inside, there we go, would fit inside this line. So when I do the division here, remember our rule, when we divide, we keep the base and subtract the powers here. So that's going to give us 10, 2 minus a minus 3. 2 minus a minus 3. So that is 2 plus 3, which is 5. Remember, minus a minus creates a plus. And then when we do 1.25 divided by 3.1, we just divide the coefficients here. We get 0.40322 times 10 to the 5th power. Now, when I convert this to scientific notation, because remember, this is too small. I need to move the decimal point 1 place over to the right. So I need to create 4.0322 times 10 to the what? Well, if this number got bigger from here, then this number, to compensate, would have to get smaller by 1. I moved the decimal point 1 place to the right. So to compensate, I need to make this 1 smaller. So it would be times 10 to the 4th power. So there is the number of beetles that would fit in the line. What if I asked you to convert that to standard form? Convert that I just highlighted in yellow. What if I asked you to convert this into standard form? Well, I would just move the decimal point 4 places to the right if it's times 10 to the 4th. So if I wanted to write this in standard form, 1, 2, 3, 4. So I'd write 40322. So how many actual beetles would fit in the line? 40,322. That would be the answer in standard form. We're going to do just one more word problem here. Typically, if we were in person, we would take some more time to work through all of these questions that we could ask, given this really interesting real information, real data table having to do with outer space and distances and such. But for this video, I'm just going to focus on number 17, which says, estimate how many times as far away from Earth the planet Neptune is compared to Venus. So distance from Earth of Neptune as compared to Venus. So these are the two numbers that I'm focusing on. Now, clearly this number's bigger, right, because they have the same exponent, 10 to the fourth, but this coefficient's larger. So how many times bigger is this than this? Whenever you see the phrase how many times bigger, you should be thinking, I'm going to have to divide. I'm going to have to divide to figure out how many times bigger. Think about what you would do if I told you that somebody was 10 years old and another person was 2 years old. How many times older is the first person? Well, it's not 8 years older. That's how many individual years older. If I said how many times older is a 10-year-old and a 2-year-old, you'd say 10 divided by 2, 5. So that 10-year-old is 5 times older than the 2-year-old. Same concept here. So I need to do 4.949 times 10 to the fourth divided by 1.21 times 10 to the fourth. Now these, 10 to the fourth divided by 10 to the fourth, will produce 10 to the 0, which is just 1, as we know from last unit. And if we divide 4.949 divided by 1.21, we get 4.09 times 10 to the 0. This is just 1, so our answer is 4.09. So about 4 times further away. You wouldn't necessarily maybe guess that when you look. This number is 4 times bigger than this number right there. If you want to pause this video and try numbers 14, 15, 16 as a little bit of a challenge, I'd recommend that. Check it out. Here is the review sheet. It's available on Schoology. I recommend that you do it and check the answer key. It's all available under the scientific notation folder. I'm going to do just a couple problems with you right now to make sure you are on the right track here. So if I want to convert to scientific notation, I'm going to start with this one right here, number 1, and then I'll do number 2 right here. All right, so currently my decimal point is right here. I need it to end up between the 3 and the 0 for my first number to be between 1 and 10. So how many spots will I need to move? 1, 2, 3, 4, 5, 6 spots I need to move. So that's 3.0, or just 3, times 10 to the 6th power for that one. What about the second question I highlighted down here? Here's the decimal point currently. I need to get it between what? What's going to make that number between 1 and 10? If I stop here, it's 49.7. That's 497. I need it right here between the 4 and the 9 to make it 4.97. So I need to move 1, 2, 3, 4 spots. So that's 4.97 times 10 to the negative 4th. Remember, if I have a small decimal, my power is going to be negative. And here, if I want to convert to standard form, I'll do this one and I'll do this one. If I have 3.4 times 10 to the 7th, what I like to do is write down my number first, 3.4, and I need to move the decimal point 7 places to the right to make it 10 times bigger 7 times. 1, 2, 3, 4, 5, 6, 7. In the blank spaces, I add zeros. I'm going to tack on 6 zeros here. Don't make the mistake of thinking that this is the number of zeros you will have. You're not going to have 7 zeros. It depends on the number. In this case, you'll have 6 zeros, because when you move the decimal point just one place, you still have that 4 there, right? So you're only going to have to add 6 zeros. Your number is 34 million. Now, if you have a negative power like this, when you write your number originally, I would write it over to the right a little bit because you're moving your decimal point to the left. So you want to allow some space over there. So 6 places to the left. 1, 2, 3, 4, 5, 6. Fill in zeros. I'm going to fill in 5 zeros. So 0.000061 would be your answer for number 4 there. Last problem I want to do with you is number 11 on the back side of the review sheet. We got a problem here, folks. We have a 10 to the 11th right here and a 10 to the 10th. And because those aren't exactly the same, I cannot add or subtract. So I need to get them to be the same. When this situation happens, boys and girls, I always take the smaller power and make it one larger. Well, how would I do that? If I need this to be a 10 to the 11th, how would I adjust this? So if I make this one bigger by a power of 10, I need to make this one a power of 10 smaller. So how would I do that? I would just move the decimal point 1 to the left. So it would be 0.38 times 10 to the 11th. Now, this is not in scientific notation right now, and that's okay, because this isn't our final answer. We're just adjusting it so that we can combine it with this to create an answer in scientific notation. So I'm just going to rewrite the first parentheses there. And now, as you'll notice, these are the same. That's good news, because now I can add and subtract, and then I just have to combine my coefficients. So when I do that, through addition, the 10 to the 11th stays the same. And 6.2 plus 0.38 is 6.58 times 10 to the 11th power. That would be your answer for number 11. There are all kinds of great problems on this review sheet. I'd recommend you check them out. Again, you have a little progress check to do today, and then your quiz is coming next week. It needs to be done by end of the day on Tuesday. End of the day on Tuesday. But I'm going to make it available. If you're ready, you can start. You will have 3 attempts. It'll take the highest score, but make sure you're ready before you start. Let me know if you need anything, boys and girls. Miss you guys. Hope you're doing well. Keep it 100.